Bismillahirrahmanirrahim. This is Pakistan International School Type, grade 12. We are discussing the chapter number 14 still and B block elements, and the topic is copper. Copper is a very important transition metal, great use, many uses in our daily life. It is a pinkish red color. Copper is a pinkish red color. Excellent conductor of electric current. Very important metal in our daily life. So we will discuss here two topics. Two topics we will discuss here for the copper. Number one is oxidation state. Number one is the oxidation states, and number two is the reaction of hexa aqua copper 2 reaction with hexa 6 aqua copper 2. Hexa aqua copper 2 with hydroxide ions, number one hydroxide ions, number two ammonia, and number three is a carbonate. Already we discussed. So there are three here. So students, oxidation state of copper, mostly copper exists in the two oxidation states, copper 1 and copper 2. And you are seeing in general cuprous and cupric. So cuprous Cu2Cl2, cuprous chloride. This is a cuprous chloride. Mercurous chloride. We don't write in the 1:1 ratio. No, it should be in the 2:2 ratios. And oxidation number of copper is 1, chlorine is 1, mercury 1, and chlorine is 1. So here in the 2 oxidation state, copper 2 chloride here and mercury 2 chloride. So generally copper exists in the 2 oxidation states written here, cuprous and cupric, monovalent and divalent. When the cupric or cuprous is not stated in the case of salt of copper, cupric is implied. Copper sulfate implies cupric sulfate, cupric chloride, cupric mercuric chloride, cupric sulfate. So most of the cuprous compounds are colorless, but the copper 2 compounds are colored, and I'm telling you, copper sulfate, which is called blue vitrol and has a blue color crystals. So the cuprous compound usually colorless and diamagnetic. They are not going to be attracted towards magnetic field, as a 3d orbital is completely filled. 3d orbital for the copper 1 is completely filled. So if there is no unpaired electron, paired field, it is not going to attract towards magnetic field. So this is a diamagnetic. Just like cuprous oxide, cuprous sulfide, cuprous oxide, cuprous sulfide, oxidation state is positive 1, oxidation state is positive 1. Which are red and black in, these are the exceptional cases. Exceptions. These cases are exceptions and they have color red and black. black. Otherwise, mostly they are colorless. Now, these are generally insoluble in water. The soluble compounds of copper 1 chloride are unstable. The copper 1 compounds which are positive 1 and they are soluble and they are unstable in aqueous solution since disproportionate. I will explain this one. What is the disproportionate? Write down this. Students, write down this. Each and everything right. When the lecture starts, you should write in your copy. Write in your copy must. See again and again. Now, disproportionate. I'll explain. Copper 1 changes into copper 0 and copper 2. Disproportionate. In the disproportionate, what we call this copper 1 changes into copper 0. This is a reduction. Reduction, oxidation number decreases. This copper 1, same copper 1 changes into copper 2. This is oxidation. So students, if one atom or ion or any substance simultaneously at the same time oxidizes or reduces are called disproportionate. These reactions are called disproportionate reactions, and you will do also in organic chemistry also. So this is a disproportionate because copper 1 is reduced to form copper 0 and this copper 1 oxidized to form copper 2. So same copper is oxidizes and reduces. So this is called disproportionate. So the above reaction is supported by the fact that when cuprous oxide is dissolved in dilute sulfuric acid, the products are formed copper sulfate and copper 0. So reactions is given here and the same approach is here. This is the same, 100% same. This is a cuprous oxide. Oxidation number of copper is +1. Yes, this is. And dissolved in dilute sulfuric acid. So we will get copper 2 sulfate. Copper 2 sulfate means oxidation of copper is positive 2 here. And also copper 0 solid plus water. So this chemical reaction is the same above. So in the copper here the oxidation number is +1 and here copper is positive 2. So this is the oxidation. This process is oxidation +1 to +2. +1 to +2. And same, this same copper, this is a 0 and this is a 1 and this is called a reduction. That is 100% same reaction. Disproportionate reaction. So dear students, if you write in short form, because sulfuric acid only the hydrogen ions are going to be involved, so 2 copper positive and 2 hydrogen ions to give a copper 0, copper positive 2, like this one. Copper positive 2, copper positive 1, and there is a 0. And if you write the water here, if you write water, or if you write cuprous oxide here, this is a cuprous oxide, so water is going to be formed also here. So student, this is the again disproportionate reactions. So if you add these 2 chemical reactions together, cuprous oxide 1 mole, sulfuric acid, cuprous sulfate water, and cuprous sulfate changes into copper sulfate. I am going to write here these 2 again. These are all same disproportionate. The whole discussion is about the disproportionate reactions of the copper. So this is the cuprous oxide plus sulfuric acid to give cuprous sulfate aqueous copper sulfate and copper 0 solid and plus water molecule. This is one chemical reaction. And second is cupric oxide plus 2 hydrogen cancel. This is cuprous oxide, sulfuric acid to give copper sulfate plus copper plus water, like this. So this copper oxidizes, this copper reduces. Most of the anhydrous students, copper sulfate, if the copper sulfate like this in your laboratory, this is called anhydrous without water molecule. Its color is white powder. White powder color of CuSO4. It is a pentahydrated. 5 water molecules are coordinated with the copper sulfate. 4 water molecules are coordinated with the copper, and one water molecule is coordinated with the sulfate. So coordination of copper ion is 4. So if the 5 water molecules attach the copper sulfate, see the laboratory color is a blue color. The color of copper sulfate is blue, and you can do experiment. When you heat the copper sulfate solid, so water will be evaporated upon heating. White solid anhydrous copper sulfate is formed. Colorless and hydrated cupric sulfate is a blue due to the formation of I told you tetra aqua copper 2. Like this one. Tetra aqua copper 2, one water will be added with sulfur. This complex you will get this. blue color, and hexa aqua copper, 2 solutions of the copper acidic solution. Yes. So copper 2 plus water, you will get the hydroxo copper, and hydrogen ion is going to be liberated. Since the outermost shell of copper 2 ion has one unpaired electron, D9 electronic configuration, so copper 2 compounds are paramagnetic. So in the beginning I told you copper 1 cuprous, their d orbital is a filled complete, they are diamagnetic, and the copper 2, they have a 3d9 electronic configuration, unpaired electrons are here, so this is a paramagnetic nature. Now reactions. So the reaction is already I told you the hexa aqua copper 2. This is the hexa aqua copper 2 with hydroxide. This is the first one. When I wrote the topics, I told you this is the last one. Hexa aqua copper 2 reacts with hydroxide, and you will get the compound, blue compound, and this is copper tetra aqua dihydroxo, blue color precipitate. It's a blue precipitate, no charge is there, plus 2 water. The name of this compound is tetra aqua dihydroxo copper, no charge, because this water is a neutral one, no charge, hydroxide is a negative one, multiply by -2 and +2, no charge. This is a tetra aqua dihydroxo copper blue precipitate. You can see also in the diagram, page number 86. Light blue color hexa aqua copper 2. Upon addition sodium hydroxide, you will get dark blue precipitate of tetra aqua dihydroxo copper. Water ligand attached to the copper ion also. In this test, copper blue color light changes into dark. This is number 1. With ammonia. Reaction with ammonia, and the previous lectures I told you that ammonia acts as a base as well as ligand. So base, I told you the chemical reactions. Now you can see as a ligand. Reaction with hexa aqua copper 2 ions with ammonia. So there is a preparation. If you have a copper hydroxide, this is a copper hydroxide, and you are going to react with ammonium hydroxide. This is ammonium hydroxide. So you will get the ligand as a copper. Ammonia. This is a copper, and there is ammonia appearing inside. This acts as a ligand. Yes. So 4 and also water 2. Hydroxide and 4 water molecules. Yes. This is when the cuprous hydroxide you can use this one also in this case. In this sense, also you can write copper hexa aqua copper 2 plus ammonia acts as a base, ammonia acts as a base, you will get this. So you will get this again. So this is a tetraamine dihydroxo copper, and this is a dark blue precipitate. So in this reaction, ammonia acts as a ligand. So ammonia acts as a base and ligand both. Hexa aqua copper 2 with the ammonia base will get tetraamine dihydroxo copper with a dark blue precipitate, solid compound. It is a compound. Okay. Now these reactions are given in your book also, page number 87. Hexa aqua copper 2 light blue color. Small amount of ammonia acts base we have to put. You will get tetra aqua dihydroxo copper, which is a dark blue color, and excess of ammonia if you are putting in excess of the water, then you will get the tetraamine and dihydroxo copper 2, which is a very, very dark blue color. Now with the carbonate, reaction with the carbonate, we done the reaction with the ammonia, we done the reaction with hydroxide, reaction with the hydroxide, reaction with ammonia, where the ammonia acts as a ligand. Now reaction with the carbonate. So hexa aqua copper. The normal copper carbonate, cuprous carbonate. This is the cuprous carbonate, and this is the cupric carbonate. Cuprous carbonate are not having isolated, but the basic cupar carbonate such as malachite, copper hydroxide, copper hydroxide, copper carbonate, they are called malachite. They are called malachite or copper carbonate. These are the ores from the earth we can get, and these are the trade names. So this is the malachite, and if you write like this one, copper hydroxide, 2 copper carbonate, blue, which is called azurite. This is called malachite, and this is called azurite, and the black blue color. Blue color is going to form here. So this is the preparation of copper hydroxide. Copper hydroxide plus carbon dioxide gas is going to be passed. So you will get the malachite, copper hydroxide dot copper carbonate plus water. You will get this malachite. So you simply get the precipitate of what you want to think copper 2 carbonate. So blue color. There the blue color of copper is the copper 2 aqueous plus carbonate 2 aqueous. You will get copper carbonate. That is the blue in color, or you can write in this form: copper hexa aqua copper 2 plus carbonate hexa aqua copper 2 with carbonate, and you will get the copper carbonate blue color, and with that 6 water molecules. So this hexa aqua copper 2 with the carbonate light blue color changes into copper carbonate, which is a dark blue precipitate. Do these questions. We done this all topics. Now students, there is one more topic, then we are going to finish this one. Society, technology and science. You should remember paints. There are many kinds, many qualities are present in the market. One is a distemper. Water paints. Water paints are called distemper. Chalk. Oil paints, plastic paints, varnish. Varnish is not a paint which we use on the wood. So, Jabir bin Hayyan, Muslim scientist, he first ever used a white paint, lacerate. The paint of lead, he used white lead, lacerate, white lead. But lead, if the paint will be old, lead paint become old 1 year, 2 year, then some dust coming from the paint, and this dust contains lead. So lead is not good for the health, for the respiratory system. That's why there are the ban on the lead paints. So somehow it is going to, they are somehow uses. Okay. Lead monoxide. Lead monoxide used as a paint. Vulcanization of rubber, strength of rubber is going to be increased by using this. Preparation of red lead. It is used in manufacture of varnished glazes, plasters and elements. Lead suboxide, black in color and found in powder form. It is used as a black pigment. It is used as a lead storage battery in the car battery. Lead and lead monoxide they use as a anode and cathode respectively. Lead dioxide is reddish brown powder used as a pigment in the paint. Then this got tripylumbic tetroxide, red lead, Pb3O4. Pb3O4, red lead. Very pretty red lead. Reddish pink color. This is used in the red paint mixed with the limestone oil. Glass industry of making glasses and used in the match industry. Red lead, Pb3O4. Basic lead carbonate, I2 lead carbonate, lead hydroxide lacerate, white paint. Used as a white paint, I told you Jabir bin Hayyan. On the wood of its good covering powder and protection, it has a more power to kill it. But the disadvantage is two. One is when it become old, when it become 2, 3, 4 years, so light is going to be affected and it become yellowish. It's not going to be white. And this lead is not good for health. Lead compounds are not good for health. Lead carbonate, lead chromate, chrome yellow. Lead chromate is called a chrome yellow. It is used a pigment under the name of chrome yellow. These zebra crossing on the roads you can see mostly they are yellow colors. So this zebra crossing paint is done by the lead chromate. On heating with a dilute alkali hydroxide, it forms orange or red basic lead chromate. So dear students, here we are going to finish this chapter. So there are 4 sections in the question papers. Still the Federal Board division for the second year chemistry. Inorganic portion and organic portion. 13, 14, 22, 23, 24. This is a B section. 13, 14, they are pure inorganic portion. And 1, 2, 3, 4, 5, 6, yes. Then 21 is a biochemistry. Number 22 is a industrial chemistry. 23 is a environmental chemistry. 24 chapter is a analytical chemistry. They are included in the section number B. 6 chapters: organic compounds, hydrocarbons, alkyl halides and amines, alcohol, phenol and ethers, aldehydes and ketones, carboxylic acid. These 6 chapters included in the section number C. And D is a mix with both, and MCQs coming from the whole book. So we completed the 13 and 14 and very big chapters. And if you see the S block elements, 13 needs 23 days, 23 lectures, only one chapter. So total I gave the 24 lectures here for the both chapters. This one chapter needs 28 days, 28 chapters including the assignments. And if you see the D block elements and F block elements, chapter number 14, which we finished here today, needs 8 days lesson. 8 days and 23. So we completed mashallah here number 13 and 14 chapters, very big chapters. Inorganic chemistry we finished here. See the exercise questions, and inshallah next chapter we start organic chemistry. Your attention is very important here, because all the these organic compound, organic chemistry topics are related with each other, technical, and you should understand very well if you will give the concentration. So this is the now inshallah second we start number 15, organic compounds. So students, we finish here. Complete these two chapters 13, 14 very, because of inorganic chemistry we finished. So we will not going to revision because of big huge syllabus is here. So you have to concentrate, you have to repeat, you have to revise very well these two chapters in all respects. MCQ short questions you have to solve. Thank you very much.